Okay, a very good morning, people. We are going to continue with where we had stopped yesterday. Rather, I would say this would be a revision lecture of what we were doing yesterday. I just wanted a clarification from you all that in comparison to yesterday's view, is today's view my view, not the presentation view as such. My view, which one is more, I would say, proper, okay, because yesterday I had an inverted screen and today I have put it right in a proper way. So was yesterday's lecture more communicative, or is today's feel of the screen more communicative?
So there is not much difference
Okay,
in screen setup.
I thought there would be a difference basically because yesterday the camera was on the top of the screen, and sorry, yesterday the camera was at the base of the screen, and today the camera I've placed it back where it normally is. That's towards the upper end of the screen as such. Okay, if there is not much difference, I did not have the time to check my yesterday's lecture, and that's why I was, and I felt it better to ask you all as well. But anyway, since you say that it's not much of a difference, it should not matter much to us. Um, yeah, so let me start presenting, and here is the presentation. I will just move it up a bit and adjust it in a way so that it becomes, yeah, it's displayed, is pinned to your screens as such. And yeah, uh, I will not go all the way back into starting with water, winds, etc., because we know that it's a continuation process from temperature to pressure, and from pressure to circulation of the atmosphere. And the upper arm of this, sorry, the lower arm of this circulation are called as winds. There are different types of winds, and there are different forces that opt on the wind. The most important one of them is the pressure gradient force, which is basically a gravitational force which pulls uh, particles from a high pressure towards a low pressure as such. And while this happens, the rotation of the earth brings in another force that's called as the Coriolis force, which makes these deflections, as they are called. Okay, and then there is a third force which is available near the surface, okay, because the surface impacts the movement of the wind in what is called as friction. Gharshan आपण म्हणतो त्याला मराठीमध्ये. This friction nearer to the surface obviously is going to be more, and as you go away from the surface, it's going to be lesser and lesser. Uh, and in that sense, normally you'll see that if pressure gradient force is operating in one particular direction, and the if this is the pressure gradient force moving in a particular direction, the Coriolis force is going to deflect it towards its right or left. Okay, basically because it's operating against the force as such. One, and if you remember, we did say that Coriolis force is not a force actually as such. It's more as an effect of the rotation of the earth and the curvature of the earth. Okay, we have gone into a very detailed explanation of how the Coriolis force builds up. Then the next force, sorry, yeah, this is the Coriolis force. Coming back to the next force we were referring to is the frictional force. So if the frictional force again is against the PGF, so normally the PGF, the pressure gradient force, is uh, uh, say opposed by the Coriolis force plus the frictional force. But as you go up from the surface, okay, you'll see that here you can see we are moving up from the surface. Why is this not working today? Just let me see if anything is wrong with this. Should have been working. Sorry, I did not test this before I started. Okay. Oh God, what is this? Let me see if pointer options pen. Seems the cell is down. Let me see. Anyway, so I'll use the cursor for the day today now. Yeah, okay, I'll use the cursor. Okay, that this is the surface, okay, all the way on the surface as such. But as you go up, okay, the frictional force is going to be lesser and lesser and lesser. And at a particular height, obviously, you'll see that it's directly going to the Coriolis force versus the PGF. And in the process of this all movement from one point to the other, okay, here, okay, this is the starting point, let us say, and it keeps moving from one point to the other. While it moves, okay, from point A to point 2, okay, you'll see that the Coriolis force has started operating. The PGF force is always going to be there, but it decreases as it approaches the low pressure as such. And at a point, what is going to happen is that the pressure gradient force balances out, or rather, the Coriolis force balances out the wind, and the the pressure gradient force balances out the Coriolis force, and the wind eventually starts moving parallel to the isobars, which is very unusual. Okay, and and this is called as the geostrophic wind. And of course, then you're going to have the gradient wind as well. I'm finding it difficult to locate my, yeah. So this is a low pressure in a circular pattern that would have, and you have the particles which are moving from this part. Okay, it starts moving directly towards the center. Okay, but eventually what happens is the Coriolis force is going to keep deflecting it. Okay, and while it deflects, okay, you'll see that it eventually starts running in a similar way to the pressure gradient force, the geostrophic wind. And however, while it moves along a curved path like this, okay, two more forces, the centrifugal and the centripetal force, come into operation. As far as the centrifugal and the centripetal force balance out each other, the gradient wind will blow, in the sense it will blow parallel to the low pressure. Okay. If it is out of balance, then of course you'll see that the wind will collapse into the low pressure, making it very intense, and you're going to have very fast blowing winds and so on and so forth in in a cyclonic condition. Okay, so gradient wind will not lead to a cyclonic condition. Remember that. This is, of course, the Coriolis force and how it tends to get deflected as it moves away from the equator. And as the time passes, you can see the deflection increases. Along the equator, however, the deflection is minimal. Okay, because the distance to be traveled is the deflective force is less, and towards the poles, you'll see that the deflection is maximum because of stronger winds as such. And let me see if it has started. No, it has not started. Um, this is a small note that I had pasted with regards the how a pilot has to gauge the exact height, because as far as the height measuring instruments are concerned, they are more related to the pressure. And if the pressure decreases or increases as the plane may move up and down as such, it could lead to a few serious issues of miscalculation. And that's why you will see that calibrating the or correcting the value of the pressure is very important in when of course you're flying as such. And then we came to an interesting aspect that we were supposed to be doing, and that's the jet streams. I did say yesterday also that these are circumpolar. Okay, they start at the poles, and that's why they are called as circumpolar. And they blow at an height of 7 kilometers to 14 kilometers. This height will vary as the thickness of the troposphere, basically because of the fact that we all know that the troposphere is thicker at the equator and it's thinner at the poles. But if you remember yesterday's documentary or the YouTube clip as such, irrespective of the thickness, the pressure is going to be different, and that is something that builds up the formation of the jet streams as such. Okay, I did tell you about this yesterday also that yeah, study of the jet streams was happening uh, much before the Second World War, but they were not exactly concreting out something out of it. It was only during the Second World War that when the American pilots took off in towards across the Pacific, of course, towards the Japanese islands as such. What used to happen is that they used to confront this while coming back. Okay, they used to be literally pushed by this, and when they reported this, they found it out that there is a particular stream of wavy movement, and that's why once it was identified, they started avoiding it when they were moving towards the west, and they started, in fact, using it when they were moving towards the east as such. So this is how study of that climatology or atmosphere helps in our day-to-day activities also. Um the properties as far as the jet streams are concerned, the height or rather the depth of this, the thickness I would rather say, is between 1 to 4 kilometers. It is written 1 to 3, but I have noted it down here that it's around 2 to 4 kilometers as such. This may vary, and it hardly matters because this is a very dynamic system. It in fact could be one, it could in fact could be two, it could be three, and at times it could be four as such. The width of this is in a few hundreds of kilometers as such, and of course the length of this is going to be a few thousands because it's a complete round that happens around this, around the poles particularly. The altitude, we have already said that because they blow around the tropopause, the thickness of the troposphere will define the altitude. If you cut through this stream of wind that is blowing in the form of jet streams, you'll see that the center of it, okay, if this is it, the center of it is going to be very, very fast, the fastest of it. Okay, and as you go out towards the outer part, you'll see that it goes on decreasing slowly as such. The circulation normally is wavy, and if it gets meandering, these are called as Rossby waves. Yes, said about this early also, and of course we did hear about this in the clip yesterday. They are very strong in winter of the respective hemispheres. Of course, if you have a winter in the northern hemisphere, it's going to be stronger there. If you are going to have the winter in the southern hemisphere, it's going to be stronger there as well. Okay, and they weaken up in summer because they are pushed back towards the poles during the summer as such. Coming to the types of the uh, jet streams, there are many types. Some of them are local, the more prominent ones. Okay, I'll just list all, but the more prominent ones are those which you are seeing in front of you: the polar jet stream and the subtropical jet stream. The polar jet stream lies between 40 and 60 degrees, if you remember. Okay, it's just about, let me see if I can, yeah, you will see that here is where you have it. Okay, this is of course the 60 degrees low pressure. Okay, so winds are going to blow from either sides into these low pressures, and it's exactly above this low pressure that you're going to have the polar jet stream as such. Okay, locations vary between 40 and 60 degrees as such. Of course, during winter they get stronger, so they could go thicker also. And then you have subtropical, which is between 30 and this is 30. So this is between 30 and 35. This is the area where you're supposed to be having the um, weaker winds, the subtropical jet streams as such. Okay. Besides this, there is something which is called as tropical easterly, and I believe and I've read it, but I'm not able to understand it properly, and that's why I'll not give you a more explanation on that. The tropical easterlies uh, are there in blow over Africa and India, and they are known to have their impact on the monsoon. Okay, that's what I've read. I'm not in a position to give you a detailed explanation about that. Then you have polar night jet streams. Polar night jet streams, obviously, the word suggests that they are going to be near the poles, and polar nights, that means winters. Okay, so during winters in polar areas of respective hemispheres, you're going to have polar night jet streams. And then you have local jet streams. You could have a small span of very fast moving winds. That's called as local jet streams as also. Um, we have spoken about this yesterday, that how we actually compare between the colder air and the warmer air as such. Okay, let us say this is the dividing line. Okay, you'll see that in the warmer air, the number of particles which are here are going to be lesser as compared to the number of particles you're going to have here. Okay, you'll see that because the density is huge, the number of particles is going to be more. You can obviously see here the number of particles are more. So obviously the pressure is not going to be the same. For the same amount of pressure to be induced, the number of particles need to be approximately same. So in that case, you'll see that the pressure that you may find here in a cold area would require a height of this in a warm area as such. Okay, I hope you are understanding what exactly is happening. Unfortunately, I'm not using my stylus, so I'm not able to draw these arrows quickly. But I've explained a significant part of this yesterday, and we are just revising, as I said. Then, what is another important part of this whole thing is indexing. Okay, you'll see that there are four stages of indexing as such. You start with number A. Okay, A, that's gentle undulating upper airflow. Okay, and then you'll see that as they intensify, they move towards the equator, and as they move, they develop the wavy patterns, and now they are called as the Rossby waves as such. And these wavy things eventually move into being um, into meandering as such. And this meandering here, you can see the meandering here. In this process, what happens is the colder air is pushed towards the equator, and the warmer air is going to be pushed towards the poles. And in this process, after the cutting off process happens, what is going to happen is you're going to left with cold pockets, and you're going to be left with warm pockets. So you'll have a warmer temperature in upper latitudes in small areas, of course, and you'll have a colder weather in lower latitudes in small areas, of course. And it was basically studying this abnormality of cold latitude or cold temperatures in lower latitudes and higher temperatures, comparatively higher temperatures in higher latitudes as such, which led to the whole study of all these things happening around us. Okay, this is how actually this should be happening. um, I will of course name you the stages A, B, C, and D as such. Okay, and I'll tell you when the one stage moves to the other. But let us just look into the, I'll have to switch back to pointer options and arrow options visible. Okay, so these are, sorry, this is, if you can see my cursor now, this is the first stage, this is the second stage, this is the third stage, and this is the fourth stage. Okay, and this is how it's actually happening here. And let us see what actually, now this is a very small one that I took up, and because I expanded it, it looks a bit hazy. But this is the equator, and as I said, between 35 and 20, you have the subtropical jets, and then you have the polar jets, which are exactly above 90 degrees as such. And in these areas, particularly the polar jet areas, you're going to have rainfall because of the low pressured base here. Okay, this is high pressure. And well, to come to the stages, I don't know where I have put it as such, but okay. Um, the first stage, okay, say this one here towards the right, the cursor you can see, or this one. This both of them are the same. It's only that the colors are different, and this one is a larger one. I purposely chose to put both of them because the shapes of the respective jet streams in the respective things are interesting either ways. Okay, if you ask me how I would place this, I would in fact, if you make me to add these 4 plus 4, I'll give you the sequence. Okay, this is going to be number 1. Okay, this is going to be number 2. Then I come here back. This is going to be number 3. This is going to be number 4. And immediately within this, this is going to be my number 5. This is going to be number 6. Okay, this is going to be number 7. And this is going to be number 8. Okay, I don't know whether I'm able to write this, but then I will just, I'll yes, use up some time here. And okay, I would say this is number 1. Sorry, this is number 1. This I would say would be number 2. Then I would say this is number 3 for me. This is number 4 for me. Okay. This is number 5 for me. This is number 6 for me. I would say this is number 7 for me. And this is number 8 for me, wherein actually number 8 should be here. And you would have a high pressure here and you would have a low pressure here. That is how I would put it, number 8. If you can see it on our screens. A similar thing has happened here as well. It's number 8. That you can see a cold patch which has come down, and you can see a warm patch which has gone up as such. Uh, how do you divide this into 4 stages as such? The first stage, if you can see number 1 and 2, I would include them in the first stage. That these are more or less straight, and you'll see that the pressure gradient force is north south. Okay, in the sense you are going to have say the higher pressure towards the low towards the lower latitudes, and you're going to have a low pressure up. So the pressure gradient, the force is going to be north south as such. However, the jet stream is blowing. It's not obviously going to be absolutely straight because winds don't blow like a ruler as such. So there's going to be a very gentle twist, but then it's not going to be wavy. That's the first stage. Okay, the straight path of circulation around the globe. Then you see that it intensifies, and then you'll see that the pressure gradient force is still north south, but the pattern starts getting a bit wavy. That's the second stage, the wavy path. This is the initiation of the Rossby waves. This is the initiation of the Rossby, Rossby, initiation of the Rossby waves. And once initiated, they intensify. They intensify as the winter gets more solid as such. And then it's going to be the third stage, which you can see. I would say it's number 6 or 5 and 6 in the diagrams in front of you. That's the third stage actually. I'm putting both of them together, wherein you have fully developed meanders. You can see that the winds are actually blowing just as a very seriously meandering river as such. What changes here is the pressure gradient, which was north south, now is seen to be east west, because the winds are either blowing south or they're blowing north. And that's why you'll see that the pressure gradient force gets east and west. Of course, this is a very unstable condition. It's not going to be easy to stay as it is. And that's why, just like in a river, you have these cutoffs and you have oxbow lakes. Okay, you're going to have number 7, if you can see, you're going to have these cutoffs. And because of these cutoffs, you'll see that you're going to have high pressure and low pressure being dislodged in contrasting locations. Okay, and the fourth stage, in fact, is called as the cutting off of the meander, and of course, you're going to have cyclones, alternating cyclones and anticyclones, uh, and of course the circumpolar thing, it goes back in its original condition as such. Okay, so it goes back to number one, stage number one, as such. So this is as far as the indexing or the index cycle of the jet streams as such. Now, I did say yesterday that the jet streams do have an impact on the Indian monsoon also. Both the tropical jet streams as well as the polar jet streams, okay, they tend to have their impact as such. This is one of them. The low pressure ITCZ, it moves into, and this of course um, is the thermal equator. If you remember, we called it as such. Another thing that happens is that let me see if I can enlarge this for you. Okay, you'll see that you have alternate highs and lows along the path of the subtropical STJ, subtropical jet stream in June and July as such. Okay, you'll see that the ITCZ is at different locations at different times. ITCZ in November is here. Okay, while it is here, you'll see that the subtropical jet streams have moved down. Interestingly, you'll see that these jet streams have split into two. Okay, you'll see that these dark lines on either side of the edge. That's basically because of the height of the Tibetan highlands and the Himalayas as such. I said that because of this vertical obstruction, they get split. Okay, you'll see that. If I can show you, this is the jet stream, and it literally gets split, and one arm is going to flow towards the north, and one arm is going to flow towards the south. It's only when the Himalayan range ends that they again unite and they move ahead as such, which can be, sorry, which can be seen here also as such. Let us try to understand the whole issue. Okay, you'll see that the jet stream has split into two parts, and you'll see that you have the low pressure here, the tropospheric depressional cyclone that you will have on the Tibetan highland. This is not a part that you should be doing for your studies as such, but this is an extension of understanding jet streams. Why is it? Obviously, somebody could say that one, that these are winds which blow at a height of minimum 7 kilometers. They may go up till 14 kilometers. And of course, the major role they play is towards the poles. Why should we be doing this? Yes, they have their impact on the local areas and the monsoon particularly, and that's why we should be understanding the jet streams in detail as such. Okay, I was to draw this in front of you. Unfortunately, I'm still not able to use my, uh, let me see. No, I'm not able to use it. So possibly, since I've been using it for a significant time, actually what may have happened is that the batteries may have run out of power. I'll check the batteries, and when we meet tomorrow, possibly the same time, I would prefer 9 o'clock. If you are not engaged by anyone else, I would obviously prefer 9 o'clock lectures. And let us try and understand some other aspects of climatology. I don't know how much time I've taken. It's less than half an hour that I have been talking to you for today. And that's all from my side as such. Let me see if anything else was to be discussed with you all. But fine. So that's all that we were supposed to be doing yesterday. As I said that unfortunately, because my stylus is not working, I was supposed to be drawing the diagram and explaining a few things about the jet streams and the indexing of the jet streams along with them as such. But that's how things are. So I'll just take your attendance. ऐश्वर्या लिमये, अजय शिंदे, अक्षय हरगुडे, असावरी काळे, प्राजक्ता जाधव, प्रतीक कोकडे, प्रीतम घोष, रेवती शिंदे, रोहित गायकवाड, ऋषिकेश अगलावे, शरयू ताकवणे, श्रेया चव्हाण, सुनील राठोड, तुषार कोथुळे, उषा वसावे, वंदिता भामरे as such. Okay, you can, I'm stopping